Good evening, everyone. What I'm going to be talking about is going to be one particular aspect that Albert mentioned very quickly. So I'm going to zoom in on that. And it's regarding architecture rules for any kind of software project. So this is obviously targeting Kotlin, but it's not limited to the backend or mobile. It could be wherever Kotlin can be used. Well, it depends on what tool you use, but we'll get to that. But the idea is that any kind of architectural pattern, whether it's Albert mentioned hexagonal architecture, there's also MVC, the sort of good old MVC, MVVP, whatever, any kind of variation. Whatever the rules are, these can be codified so that, the idea is so that you prevent architectural drift. As we all know, code evolves, you have new contributors and so on, and very quickly you can get all sorts of violation to the rules and you get the drift I'm referring to. And that could actually cause some quite important problems for maintainability of the project. Any project, whether it's mobile, backend, whatever, enterprise. So that's what we're going to be covering. Right, so I'm going to, as I said in my intro, this is not about one particular pattern, although I'm going to be focusing on one that Albert mentioned. And I can explain why I picked the proponent adapter. Precisely because, and that's, I swear I did not collude with Albert, but it turns out that it's one that we often prefer because it improves the testability of our systems. It means that when you want to write some test against a third party, well, to verify a particular contract, you don't have to actually plug to a third-party system and have some really slow-running test because you want the fast feedback loop, right? So I'll stop with the justification, but ported adapter it is, and we're going to go with that, right? So just a quick reminder, I don't know if you can see that all right, it's big enough. So as you can see on the screen, what you have, essentially, if you look at the rectangle, you've got two sides. You've got the driving side, and you've got the driven side. This is also referred to as primary and secondary. So incoming, outgoing, right? So the idea is that you have some ports that are part of your application, and you've got the adapters that will be an implementation of those ports, and you can have multiple implementations. So you could have REST, CLI, what have you, or even a desktop interface, whatever. So that's the idea for the driving side. And on the driven side, on the right-hand side, the idea is that you have, again, some ports, but are about where it's the application actually that's going to be driving the communication with those subsystems, whether it's the database, a message service, a notification, so on and so forth, right? And at the core of it, you've got the domain, right? So that's for this particular pattern. And what we want to do, we want to make sure that the concepts are not, well, we don't have the drift from the concept, right? So yes, the quick recap is we've got the domain model, the use cases or the business logic, the actual application that's actually communicating with those, and you've got the ports in and out. So that's kind of the protocol, if you like, and you've got the adapters, which are the concrete implementations, right? I think that's got a bit. Yeah, that's probably better. And the cardinal rule is that the dependencies go inwards, right? So the implementation, what do these rules look like, right? So I'm not going to show actually the implementation on this slide, but this is just to give you a flavor. So this is where we say, for example, the domain model cannot access maybe an adapter, right? Definitely not, right? Or the ports do not access the application. So things that are, I mean, it's common sense. You just, the sort of the guiding thing is that you have this diagram, and the idea is to have some tests that represent what these rules are, right? So let's go back to that. Yes. So the reason why, for example, someone eagle eye might ask, why did you use the testable annotation? Well, that's a marker annotation to help IDEs to discover tests, right? So it's not, of course, it comes from the JUnit platform, but it's actually implemented by both the JUnit engine and also by ArchUnit, right, which we're going to look at, right? So now let's see how they're implemented, sort of side by side. And we're not going to be able to cover all the rules. I just give you, this warning because, again, we're limited in time. But we're going to see some action, right? Hopefully. So that's why I use the boom emoji because, anything can go wrong now, right? Right. So there you go. Right. Is that readable? You even got the git blame there. You notice that? Right. So this is basically the interface defining the rules that I had on the slide, giving you a preview, right? And the idea is that we can have an implementation using ArchUnit. And I'm sure I didn't make the best use of ArchUnit, so it might not be totally fair. And we're going to look at the similar implementation with a Konsist, right? So which one should we go with? Well, we could let's go for the domain model members do not have outgoing dependency, because that should be a fairly easy one, right? So let's do, right, so we go look at that. So let's have a look at it for ArchUnit. So you can see here you have something that uses a Fluent API, but it's definitely, and that's going to be counting against ArchUnit. It comes from Java, right? ArchUnit predated. I mean, it definitely shows in some of the API. It wasn't built for Kotlin, right? So, but you can implement some of the rules with it, right? So, for example, here we have, and it should read fairly easily, right? Let's say no class that reside in package domain model depends on class that are. Then here you have to list the packages as strings, which obviously can be quite brittle as well, right? And also you have to supply. It's sort of the mechanism that ArchUnit uses is it scans the class path. So depending how you configure it, and especially if you have any kind of package cycles or anything like that, things could be really slow, right? So that's definitely a particular problem. So as I said, we're going to compare side by side. So let's look at the similar. So you say domain, I should have saved that. Members. So in Konsist, it's a one-liner. Oh boy! So what happened there, right? So what we have. Okay, this is my use of Konsist. It's actually not necessarily a canonical. If you look at the documentation, it might not look that concise, but still, it's more concise than what we've just saw with ArchUnit. So I make use of a particular function we can go to right at the bottom that basically takes a scope. So this is part of the Konsist API to say, you could define some scopes. There are some built-in scope from production. So it will look only at the production code. And then it has this assert architecture, which takes essentially a block which has the rules in it, right? So let's go back to where we were. And what we have inside could be essentially one or many rules, right? So here we only have one because the test is about the model layer. And as you can see above, we have other layers defined, right? So they're defined in one place, and we're going to be using them throughout. So just for the sake of speed, I'm going to go down to one where we have two, right? So ports do not access the application, adapters, or domain hubs. So you can actually have as many lines inside that block as you want, right? As needed. But I think generally the best practice is to try to not have too many assertions in the test, isn't it? Right. So here we have ports layer depends on model layer, but it also does not depend on. So I need to say this. Thank you, if they watch this later, to the Konsist maintainers, because they've added. So this was mentioned on the Kotlin Slack. Is there a does not depend on and didn't exist? So this got added in the last release in time for this talk. That does not depend on, because until then you can only say it depends on this, depends on that, but you didn't sort of have a negative assertion, right? So and then it's not that. Sorry. Yeah. Right. I saw something jumping and I was like, okay. So. I'm not going to go through all of the rules, but they follow the same pattern, right? So where you have a block of like several lines of the Java Fluent API, blah blah blah, and then with some good Kotlin hygiene, you can reduce it to something that's very concise, right? So let's go back because I mentioned a few things here. Let's go back to the summary. Right, so in this summary, we have pros and cons. So we have ArchUnit on one side, Konsist on the other, right? So ArchUnit undeniably has a rich and stable feature set. In fact, there are some features that ArchUnit has that are not yet implemented in Konsist, right? So that's something worth bearing in mind. One of them, for example, is detection of package cycles, right? Unfortunately, that's not available yet, right? So there may be situations, especially on legacy projects or large code bases, where you may want, in fact, it's not a binary choice. You may want to use both, right? Maybe for the edge cases, you may still want to use ArchUnit. Right? The cons, one thing I mentioned, you saw it yourself, is the verbosity of the Fluent Java API. I mean, it's, you know, it's discoverable. It's got that going for it, but yes, it's difficult to build something that's built for Kotlin. The class path scanning is a massive problem. Why? Because although you could argue that for running the test, you still use the JVM, but it means that it limits at least the use of Konsist to the JVM, right? Sorry, Konsist, ArchUnit. Oops, no one corrected me. So it limits the use of ArchUnit to the JVM. And ArchUnit does also all its magic understanding of Java classes literally from the bytecode that's loaded in memory, right? So it can be quite slow if misconfigured. And something that we didn't touch on, but you can, in both, you can create some custom rules for your assertions, but the developer experience for ArchUnit is pretty rough. Like seriously, because again, it's not like you can take lambdas and you could create some rules like that in one line. No, it's a Java API, so you have to conform to the Java idioms, right? Konsist, tailor-made for Kotlin. Not only the API is definitely sort of feel like, I can't say Kotlin native, but you know what I mean, right? It's native to Kotlin. It scans the Kotlin files. That's a massive difference. Is that it does all of it, you know, what it does from the understanding of the language from the file system, not from the actual compiled code. So yes, I should have mentioned that. The class path scan means that you have to compile first, right? Yes, because that's another, I would say another con. It knows the language features. It understands the constructs of the language, so it's able to, you know, check more thoroughly what is allowed and what is not. And because it's not tied to the JVM, you can use it for an Android or multi-platform project. The documentation, to be fair, ArchUnit has an extensive documentation as well, so that's not necessarily, you know, I should have added, I think I was limited in the size of the slide. And the cons, yes, I mentioned the missing features, right? So the missing features, as I said, it's not a binary choice, it doesn't have to be. You could import both and check the edge cases. So just a quick list of resources. So this, what I showed you is in GitHub under this repo. I don't know if you can see, yeah, you should be able to see it. There's some documentation. So on this slide, I've only listed the Konsist documentation, but the GitHub repo, the README has the ArchUnit documentation as well, which I think has a good rationale for why it's important to test your architecture, or at least the invariants, the rules, and so on, right? So that's, I think I'll suggest checking that out. And again, I repeat, because this kind of discipline and stuff we're talking about, tend to think, oh, that's for back-end Kotlin guys. No. This is for any kind of Kotlin development, right? There's a quick YouTube video where the author of, well, the main contributor to Konsist pairs with Dave Leeds, who's a good YouTuber. I suggest looking at that content as well. And finally, that's me, Frank. I'm a principal consultant. I specialize in platform engineering, DevOps enablement and acceleration, and mentorship of software engineers. You can find me on LinkedIn. I definitely don't have X. That's a political statement. And I'll leave you with this quote where, again, what I started the talk with, where architectural drift can quickly grow into architectural technical debt that no one wants to touch, right? So it's good to have something like that in place, some automation. And last but not least, Albert started with this. We were all both part of Clockwork with Dave and a few others. And yes, follow us on LinkedIn. Have a chat with us later here or down the pub. Thank you very much. Yes?
So when I played with ArchUnit,
Yeah.
I found that the onion architecture, I couldn't separate out the separate adapters. You couldn't stop it. You couldn't prevent bleed from one adapter to another.
Ah.
So is that something? Is that something that's relatively easy to do in Konsist?
Yes. So both have an API for dealing with slices of code. So you can. There are. If you check the document, you will find a particular section on preventing something cyclical within. So, for example, a good example of that, like when we talk about the whether it's the adapters, like an adapter using another adapter, that would be a no-no, right? And yes, that's definitely covered, but it's not using the particular API I showed you there. So this is look for specific slices, right, where you actually declare what packages but as I said, in Konsist, there's no detection of package cycles, right? But you can, I think there might be something about preventing things inside the same package from using each other. So check that out. Any other question?
How far left is it shifted? Can you do it in ID? Like, you type the wrong thing and it's just like red.
Right, so those kind of tests. So interestingly, Konsist documentation suggests using running or even having those tests separate from your normal tests. I'm not sure I agree because that requires like a special invocation. Also, that might suggest that maybe because they're slow, or I mean, why they're slow, maybe they shouldn't be, you know. So I would prefer to have them as part of all the other tests, so that when you just check, you run the test for your project, everything is checked locally and also in CI, right? Again, for the fast feedback loop. But yes, the ID itself, I mean, you can run all the tests, but people don't tend to do that. They might run a single test, right? So this is like, it depends on the kind of setup you have. But yes, you want to know as soon as possible. Ideally, as you type, right? But yes, maybe not with, we'll have a chat later. Yes?
Quick one just on testing frameworks. Does it depend on anything specific?
Not at all. No.
Unify?
Well, yes. So ArchUnit has a test runner, but which is, I think, built on JUnit 5.
Yeah.
So it's for JUnit 5. I think it used to support JUnit 4, probably still does. I wouldn't vouch for Konsist supporting JUnit 4. Hopefully you're not in that situation, but you never know. But yeah, generally, I think Konsist support cotest as well, right? So you could also use cotest for this. I've not tried. I tend to prefer the vanilla JUnit 5 for running all the tests, but yeah, it's. Anything else? Yes.
I'm new to the whole idea of architecture testing, so this might be a stupid question. How opinionated is it about the patterns you're using? Because obviously the one you've outlined, you know, that's a standard enough pattern. But it sounds like you have had to, you know, decide all of those rules. Like, are there community contributed repos of like, you know, oh well, this is MVC. Here's some.
Yeah.
Construct that.
So I think in the documentation there are mentions of certain architectural patterns. So clean, or it's referred to as clean, or onion, or I think they're kind of all sort of neighbors, hexagonal, ports and adapters, and so on. I think you may have some for MVC, etc. But I think Konsist in its API has some assertions that are specific to a particular pattern. Of course, they would have implemented those rules, not you, how that's configured. But generally, it's going to be as opinionated as you are, right? So just make sure that you're happy, or your team is happy with the rules that are laid out, and then you should be good to go, right? Anyone else? Yeah?
How do you maintain the rules? How does the team maintain the rules?
That's a good question. Well, in my experience so far with them, not everybody is interested in it, in the rules, right?
That's why it's there.
Yeah, I mean, it's, should say exactly how it is, right? So not everyone's interested in it. Generally, it tends to be the people that have that particular focus, right? They will codify the rules, and then people just accept them, right? In that respect, yeah. I mean, in that respect, it's not that different from any kind of linting, right? Where, so someone at some point decide, oh, you know, we should, you know, disable this particular rule, enable this one, and so it's not. This is linting for architecture, right? Essentially. Yeah. Any question? No. So yes, but really, ideally, in a nice and collaborative world, right, where everybody's participating, you would have the team agreeing on code conventions, on architectural patterns, and so on and so forth. But let's be honest, right? It's not the case. Right?
They tend to emerge. So
Yeah. That's charitable, but that's yes. Yes. Anyone else? I think we're good. We're set.